So in this section of the notes, we're going to look more specifically at the angle of depression. So as a reminder, this is when you are looking down from the horizontal. So here's your line of sight if you're just looking straight out ahead of you, but the angle below that horizontal is what we consider to be the angle of depression. So if you're looking down to something. So in example 5, we have a lifeguard is sitting on a platform looking down at a swimmer in the water. If the lifeguard's line of sight is 8 feet above the ground and the angle of depression to the swimmer is 18 degrees, how far away is the swimmer from the lifeguard? So I'm just going to draw this from scratch, and I'm just going to show you that you can do things like just having a point here and saying that this is the lifeguard, and then a point down here and saying this is the swimmer. You can have drawings like that. There's nothing wrong with that. They don't have to be of people or of water or anything like that. So it says the lifeguard's line of sight is 8 feet above the ground. So that means directly above the ground, this distance here is 8 feet. And obviously then we would have the water and then over here to the swimmer. So you can imagine that this is another leg of that triangle. And if we were to connect these, you can see that we've created a right triangle here. However, the angle of depression being 18 degrees is actually not part of this triangle because remember, it's the angle of depression from the lifeguard, and the angle of depression is always from a horizontal. So we would have to actually draw in the horizontal line that the angle is beneath. So this is actually the angle of depression right here. So this is the 18-degree angle, which is not inside of this particular triangle. However, can you see that this can also be a triangle up here, right? If I use that horizontal line and I drop this perpendicular, so this is a right angle, then this could be the 18 degrees. And this distance from here to here would also be 8 feet. So I could also use this triangle, or I could use this triangle. And something to consider is I could have this 18-degree angle, so therefore, since this is a 90-degree angle, I could know what this is by doing 90 minus 18. So I could use this angle if I really wanted to use this triangle. And it's also true that because these are both right angles, this horizontal here is parallel to this horizontal down here, which means this angle, 18 degrees, is congruent to this angle, also 18 degrees, because these are alternate interior angles. So you have lots of options moving forward. But what is it that we're looking for? It says, how far away is the swimmer from the lifeguard? So here's the swimmer and here's the lifeguard. So this is the distance that we're looking for. So I'm going to label this X. And I want to show you that no matter which triangle you use, you're going to have the same setup. So if I use this triangle, which I'm highlighting right now in green, the equation that we would set up, well, this side is opposite and this side is hypotenuse, which would be a sine function. So I could say that the sine of 18 degrees is opposite, which is 8, over hypotenuse, which is what we're looking for, x. Now, if I didn't want to use that triangle and maybe I wanted to use this triangle, which I'm highlighting poorly, but I'm highlighting in orange, here I have the 18-degree angle and the opposite side and the hypotenuse. So it would still be sine of 18 equals 8 over x. So that's definitely the equation that we're looking to use. So I can put the sine of 18 over 1 and use our cross products. 8 times 1 is 8. X times the sine of 18. So to isolate x, we'd want to divide both sides by the sine of 18. And then we'd have to use our calculator to do 8 divided by the sine of 18. And when I type that in, I get approximately 25.9 feet. So that is the distance between the swimmer and the lifeguard. Let's look at another example. A pilot in a helicopter spots a landing pad below. If the angle of elevation is 73 degrees and the horizontal distance to the pad is 1,200 feet, what is the altitude of the helicopter? So if this is our helicopter and there's a landing pad off in the distance but below, so here's our landing pad, it tells us that we're looking for the altitude. So I know that that is the distance from the helicopter to the ground, which will make that 90-degree angle with the ground. So I can kind of see this triangle that we're starting to create. I could connect the helicopter to the landing pad. But let's talk about where our angles belong. So it says if the angle of elevation is 73 degrees. So that's talking about this angle here, because remember the angle of elevation, this is above a horizontal. So you'd be elevating your eyesight to look from the landing pad up to the helicopter. So you could think of this as 73 degrees. Keep in mind, this also means that it's true that the angle of depression here from the helicopter down to the landing pad would also be 73 degrees because of alternate interior angles. So it turns out that they were talking about angle of elevation here, but it also could have been the angle of depression here just because of alternate interior angles. So the horizontal distance to the pad, so this distance here, since it's horizontal, this is the 1,200 feet. And we're looking for this altitude. So we're looking for this height here. So we can use this triangle, or like I said in the last example, you could use this horizontal here along with that side and use this triangle, which of course this would then be 1200 and this would be x. Either way, we're going to set these up the same way. We have the opposite side and the adjacent side. So this is going to be the tangent of 73 degrees equals x over 1200. So our cross products being set equal to each other, we have 1 times x, which is x, equals 1200 times the tangent of 73. Using our calculator to type that in, we would get x is about 3,925 feet. So that is the approximate altitude of our helicopter. And number 7, building A is 480 feet tall and building B is 654 feet tall. So let's say that this is building A, and over here we have the taller building, which is building B. So just to keep these straight, I'm going to go ahead and label building A and building B. It says the angle of depression from the top of building B to the top of building A is 42 degrees. So you have to envision that you're looking from the top of this building down to, whoops, let me use the line tool and that'll make it a little bit easier. Top of this building down to the top of this building. But where does the angle go? Well, it's the angle of depression from the top of building B. So it's actually from this horizontal. So this is my angle underneath. This angle right here below the horizontal is 42 degrees. So it wants to know how far apart are the buildings. So I want to know this distance here. So I can see that this would be my right triangle. But the key is knowing what is this side length right here. So if building A is 480 feet tall and building B is 654 feet tall, since this is the difference between 654 down to 480, I can subtract 654 minus 480 to find the side length. And that would be 174 feet. So this side of the right triangle is 174. So to find this, I would be using tangent again because this is opposite and adjacent. So we could say the tangent of 42 equals 174 divided by x. So cross products mean 174 would equal x times the tangent of 42. And then to solve for x, we would have to take 174 and divide it by the tangent of 42. And when you do that in your calculator, you get approximately 193.2 feet. So that is the approximate distance between the two buildings, that horizontal distance that we're looking for. We have one last problem to look at. Zach is standing at the top of a lookout tower and spots a water fountain below. If the lookout tower is 75 feet tall and the angle of depression is 28 degrees, what is the horizontal distance between Zach and the water fountain? So let's say here is Zach. He's on the top of a lookout tower. So here's our tower, and it says the tower is 75 feet tall. And then over here on the ground is the water fountain. And we're looking for the horizontal distance between Zach and the water fountain. So the horizontal distance would be this distance here that I'm drawing in. So I'm looking for that distance. So I can visualize our right triangle, but where does our angle belong? Here's our right angle. So it said, as a reminder, the angle of depression from Zach to the water fountain is 28 degrees. So we need to draw in our horizontal line first. So here's our horizontal, which means this angle below the horizontal is your angle of depression. So this is your 28-degree angle. So a couple of things that you can do. We can remember that this would be parallel down here. So by alternate interior angles, then this is also a 28-degree angle, and you can utilize this triangle. Or you could have continued this horizontal line and connected it with a vertical over here to create another triangle over here, which we know this would also be 75 feet long, and we'd be solving for this length here. Third thing that you could have done is you could have figured out what is the angle measurement here, because I know this whole angle is 90 degrees. Lots of options, but I'm going to go ahead and I'm going to utilize this triangle down here. So I can see from 28 degrees, this side is our opposite side, and our adjacent side is where x is. So again, we're using tangent. Whoops. So the tangent of 28 equals 75 over x. So one more time, we're solving this proportion. 1 times 75 should equal the other cross product, which is x times the tangent of 28. So to isolate x, we would divide both sides by the tangent of 28. So in our calculator, we would do 75 divided by the tangent of 28, and that would give us approximately 141.1 feet. So the horizontal distance, so not this distance straight from Zach to the water fountain, but the horizontal distance from basically the base of the lookout tower over to the water fountain. This would be about 141 feet away.